We are currently living in a very difficult situation where the entire planet Earth has been affected as a result of the coronavirus pandemic. The objective is to present a cost-effective, non-contact infrared temperature measurement thermometer in order to enable the general public to use it. The use of non-contact thermometer is perhaps the only viable option for it to be used in hospitals, schools, your house, or in the community. In this video, I will illustrate the software algorithms and models of the Intelligent Infrared Digital Thermometer medical platform. The software engineering prototype was developed in Python and C++ languages, and the BIOS resides in the system firmware. The artificial intelligence infrared thermometer system is integrated by a sophisticated optical system, a photodetector, the signal amplifier, the signal processing and display, the radiation of the measured object, and the feedback source is adjusted according to the modulator and input to the infrared detector system. The difference between the two signals is amplified by the inverse amplifier, and the temperature of the feedback source is controlled so that the spectral radiance of the feedback source is the same as that of the object being measured. The artificial intelligence infrared thermometer system is integrated by a sophisticated optical system, a photodetector, the signal amplifier, the signal processing and display, the radiation of the measured object, and the feedback source is adjusted according to the modulator and input to the infrared detector system. The difference between the two signals is amplified by the inverse amplifier, and the temperature of the feedback source is controlled so that the spectral radiance of the feedback source is the same as that of the object being measured. Emissivity parameters. All objects reflect, transmit, and emit energy, and only the emitted energy can indicate the object's temperature. So, when the infrared thermometer system measures the surface temperature, the instrument can receive all three kinds of energy caused by infrared energy reflected from other light sources. The optical system of the infrared thermometer collects energy from a circular measurement spot and focuses on the detector. The optical resolution is defined as the ratio of the distance from the infrared thermometer system to the object to the size of the measured spot. The larger the ratio, the better the resolution of the infrared thermometer and the smaller the spot size to be measured. The intelligent infrared thermometer system is a non-contact diagnostic tool that can scan and image the thermal radiation of objects and display data on its own OLED subsystem display. It has the advantage of wide measurement range, fast temperature measurements, and high accuracy and high sensitivity. Infrared is an electromagnetic wave with a wavelength between the microwave and visible light. The wavelength is between 1 millimeter and 760 nanometers, which is visible light, longer than red light. So, therefore, anything above absolute zero, minus 273.15 degrees centigrade, can generate infrarays. Therefore, as the temperature rises, the radiation peak shifts to the shortwave direction and satisfies the wind shift theorem. The wavelength at the peak is inversely proportional to the absolute temperature, T, and the blue curve is the line connecting the peaks. This formula tells us why the high temperature thermometer works mostly in the short wave and the low temperature long range wave. The rate of change of radiant energy with respect to temperature is larger at the short wave than at the long wave. That is, the thermometer working at the short wave has relatively high signal to noise ratio. That is high sensitivity and strong anti-interference.
The knowledge-based dataset algorithms enable analysis of parameters that include all cases of novel coronavirus recovered, updates of confirmed deaths, and the number of active cases. The data analytics algorithm is primarily built with Python and uses Anaconda Spider dependency for data transformation, number crunching to generate the estimates. The graphical representation tracks the number of infected cases and help visualize the relative scale of spread of COVID-19 coronavirus. The data science software algorithms graphics provides updates with new data as it becomes available. The numerical Python, NumPy, is the library equipped with useful resources that make Python into a powerful scientific analysis modeling tool. The library empowers Python with data structures to perform multidimensional arrays and matrices calculations. The write callback function on the above software algorithm retrieves matplotlib library to perform animations in this specific development and this particular design. Data science coronavirus software algorithm design methodology. The methodology consists of import matplotlib library and import of NumPy. Define coronavirus parameters, that is incubation, whether if it is severe, and the fatality rate. Set virus as a class. Create annotations such as infected, death, and recovery. Create member variables that includes number infected, number recovered, number of death, and fatality rate. Then define the initial number of population, such as currently infected, total number infected, thetas indices. Then define the virus spread, exposure to virus before and after. Assign symptoms, assign recovery, update status, and function animation, which is a graphical representation of the software algorithm architectural model. For animation in matplotlib library, I created an object of a class called matplotlib.animation. The three important parameters to be given are fig, function, and frames. Frames contain the variables on which the animation is to be done. Here I save the animation into an MP4 file.